We are done with the mesher and FFlex body edit modes. This time, I will introduce the functions of assembly mode related to flexible bodies. In the dialog box of FFlex body, there are three additional tabs that the rigid body does not have: FEinfo, Connecting Parameters, Node Scope. FEinfo shows the mesh information of a flexible body. The number of nodes and the number of elements are displayed. You can also check the number of elements based on each element type. It is possible to open the display dialog box by clicking this display button. Connecting parameter is a feature for advanced users. Connecting parameters are the numerical characteristics for the relation between a flexible body and another body which are connected by joint or force. When the use force connector option is used, the simulation speed and convergency are improved, but it can be less accurate. As for the mass value, it is recommended to use as small value as possible. In a flexible body, the node results are written to the results file only when the nodes are defined as output. However, it is possible to check the results of nodes that are not defined as output. Select non-output node and select the node you want to check the result of. The result is plotted in the scope dialog box. Here is what to know about marker. The markers belonging to the rigid bodies are connected to the body directly, but the markers belonging to the flexible bodies are connected to one specific node, and the relative position between the marker and the node does not change. So, in the FFlex body marker dialog box, the reference node ID and its relative displacement are displayed. By default, when a marker is created, it is connected to the node closest to the marker. When converting a rigid body to a flexible body, the joints and forces are preserved using the G-modeling technology. But sometimes users need to create new joints, forces, and contacts. Basically, you can create them in the same way as a rigid body. However, in the case of joint and force, FDR must be created in advance, and joint and force must be created on the FDR's master node location. For contact, it is recommended to use the GeoSurface contact series. For 3D contact, you need to create a patch set in advance, and for 2D contact, you need to create a line set and define the contact using it. And unlike a rigid body, self-contact between different patch sets and line sets of the same body can be defined. Let me create a joint and a contact for a simple model. An FDR and a patch set have been defined in advance. The joint is created on the master node location of the FDR. The contact is created between a rigid sphere and a patch set of a flexible cylinder. After running a simulation, we can see that the joint and contact work properly. In the previous lecture, I mainly introduced how to convert a rigid body to a flexible body using mesher. However, many users often import mesh data that were created in advance. Meshes created in RecurDyn as well as meshes created in other software such as Nestran, ANSYS can be imported. There are three options when importing a mesh file. The most common option is body option. At this time, the original body disappears and it is replaced with the imported mesh data. Please note that there is no unit system in the mesh data. The unit must be carefully specified when importing mesh file. This is a demo video for importing a mesh file. After specifying the reference point to import the mesh, confirm the unit and click OK. This shows how to replace a body with a mesh file. After selecting the body option, select the file and confirm the units. The reference marker or origin must be specified carefully. GManager is a function that will be used very often for MFBD. This feature allows you to easily convert rigid bodies to FFlex bodies, FFlex bodies to RFlex bodies, or FFlex bodies to rigid bodies. When creating a mesh for the first time, it is recommended to enter the mesher mode through this GManager rather than the mesh menu. Let me convert a rigid body to a flexible body using GManager. Click GManager, select a body, and click the execution button to enter the mesher mode. After that, mesh, and exit. How simple is that? This time, I will turn the flexible body back to the original body with GManager. Click GManager and select the body. It says convert FFlex body to. If you click execute, the flexible body is converted back to the original rigid body. Merge is a function that merges two flexible bodies into one flexible body. The nodes of the connecting parts must match exactly. Conversely, split is a function that divides one flexible body into two bodies. When using split, since the element set specified by the user is divided into each separate flexible body, it is necessary to specify the element set in advance. Load is used when you want to apply various kinds of distributed forces to a node set or patch set. Load EX and load USUB applies the load to each node directly. Pressure applies the load to the patch set as pressure. Thermal is used to consider the thermal load caused by temperature. RecurDyn supports these heat transfer functions, so-called FFlex thermal, and this thermal load cannot be used together with this FFlex thermal. As you can see, in case of load, the specified value for each node is applied as it is. In case of pressure, the magnitude of the applied force can vary according to the size of patch. For pressure, a converted value is applied to each node considering the area of the entire patch. RecurDyn supports contact between various combinations of different body types. It also supports self-contact within one flexible body. Several kinds of contacts are supported, but I recommend to use this GeoContact series. The contacts shown on the right were developed in the old version of RecurDyn. GeoContact is newer version and its performance is much better. When defining a contact, patch set or line set must be created in advance. The contact parameters are the same as those used for rigid bodies. FFlex thermal is a function for the heat transfer analysis in a FFlex body. The temperature change of the flexible body is calculated considering heat conduction and simple convection heat transfer, and the resulting strain and stress are calculated. Please refer to this link for the details. I will end this lecture here and continue it in the next one. After watching all the MFBD kit courses, don't forget to try the workshops in the below link here. Thank you.